Question 8a. A particle moves according to the function x of t is equal to t to the fourth power plus 3t cubed minus 6t. Determine the displacement after 8 seconds, the velocity after 3 seconds, and the acceleration after 2 seconds. Alright, so displacement is really the distance in a specific direction. You should remember that. Now, x is the distance traveled and t is the time taken in seconds. Now, displacement, you're going to find x. So for part A, x of 8, because t is equal to 8. It's after 8 seconds. X of 8 is equal to 8 raised to the power of 4 plus 3 times 8 cubed minus 60. So, let's use our calculator and work that out. Now, here we have, we're going to have to put it in advanced mode to see the power. So we have 8 raised to the power of 4. We could find out what that is. That's 4096 so far. Plus 3 times 8 raised to the power of 3. The 3, yeah, equals. So we have 5632 minus 60 equals 5572 we have. So we have 5572. You're not given any units, whether it's centimeter, meter, whatever it is. So we just say units. Alright? Now, velocity. Remember, velocity is the rate of change of distance with time. The rate at which distance is changing with time. It's meters per second because we're looking at distance x per time. So what we're going to find is the derivative of distance with respect to time. So it's dx by dt. Alright? That means we're going to differentiate with respect to time. So here, dx by dt is equal to, remember this is t to the 4. When you differentiate t with respect to t to the 4 with respect to t, you're going to have 4 come down here. So you multiply by the power. Then you're going to subtract 1 from this old power to get a new power. Alright? Plus, you have 3t cubed. You multiply by the old power here. 3 is going to come down here as 3 multiplied by 3t to the 3. Subtract 1 from the old power to get a new power. Alright? Minus. Well, when you differentiate 60, you get 0. You differentiate a constant, you get 0. So, therefore, what we have is that dx by dt is equal to 4t cubed plus 3 3 is 9 t squared. After 3 seconds now. That means when t is equal to 3, Remember now, this is the velocity, which is speed in a specified direction. The velocity, dx by dt after 3 seconds is going to be 4 times 3q plus 9 times 3 squared. So let's work that out with our calculator. We have 3q is 27. So that's going to be 3 raised to the power of 3. You get 27 times 4. That is 108 plus 9 times 3 squared. 3 3s is 9. So it's 9 times 9 equal 189. So looking at 189. If it was meters per second squared, it would be meter per second squared. If the distance was in meter, but we don't know what the unit is, so it is units per second squared, whatever the unit is. Alright? Now, 189 units per second. No, not per second squared. Why am I saying per second squared? It's not acceleration. It's units per second. It was, if distance was in meters, this would be meters per second. But we're not told, so this is unit per second, whatever the unit is. Alright? Now, we want to find the acceleration after 2 seconds. So that's part C. Now, the acceleration, you know that the unit, the general unit, is meters per second squared, which is meters per second per second. In this case, we have units per second squared. Now, acceleration is the rate of change of velocity with time. Now, this is velocity. This is velocity, rate of change of distance with time. So, to get the rate of change of velocity with time, we're going to differentiate this. Alright? We already differentiated, so we make a second differentiation. So what we're really finding is d squared x by dt squared. So here, remember, what we did to find velocity is we differentiate to get dx by dt. To get acceleration, we differentiate again. We differentiate dx by dt with respect to t. Alright? So, here, what we have is 4 dx by dt. Dx by dt is equal to 4 t cubed plus 9t squared. 4 t cubed plus 9t squared. So, d squared x by dt squared is equal to, remember now, we have 4t cubed. We're going to bring down the 3 multiplied. Alright? So I have 3 times 4 today. Subtract 1 from the old power to get the new power. Plus, we have 9t squared. Bring this down, multiply by 2. So we have 2 times 9t today. Subtract 1 from the old power to get the new power. So we have 3 fourths 12t squared plus 2 nines 18 t to the power of 1, which is just t. Now, this will give you the acceleration, and the acceleration after 2 seconds. So therefore, what we have is the acceleration is d squared x by dt squared. So that is the rate of change of velocity with time, equal 12t squared plus 18t. Alright? So remember, this is the symbol we use. The fact is, what we really found was d by dt of dx by dt. So we call it d squared x by dt squared. That's what we call it, right? And this is what we end up with here. Now, at t equal 2 seconds, what we have is that d squared x by dt squared, the acceleration, is 12 times 2 squared plus 18 times 2. That will give you 2 2s 4, 12 4, 48 plus 18 2s 36, which is 48 plus 36 is what? 8 and 6, 14, bring down 4, carry 1, 3 and 4, 7, 1, 8. It's going to be 84. And it is, well, if it was in meters, if distance was in meters, then the acceleration will be meters per second squared, which sometimes written like this, sometimes it's written like this. In this case, we say units per second squared, which would be the acceleration.